Hello everyone, my name is Raja. Today I'm going to tell you about a magical sequence which does not involve complex mathematics.
Can you guess the next number in the given sequence? Well, let me read the sequence for you. 1, 11, 21, 1211, 1 lock 11,221. 3 locks 12,211. Well, I will give you 10 seconds time to think. Think different.
The next number is 1 crore 31 locked 12,221. Well, did you guess the number? If not, we are here to explain you. Come on, let's get started.
Okay. Let me explain this series. Well guys, just remember the name of a sequence once. That is nothing but look and say sequence. As you observe the series carefully, you can understand that there is no maths involved in it. First of all, read the series by pronouncing the digits separately. When you take the first number, that is 1, we have to call it as 1, which is nothing but 11. And then the next number 11, now read it as 2 ones, which is nothing but 21. And then see the next number 21, we call it 1211, which is nothing but 1211. In the same way you can do it for all the numerals in them. For the better explanation, I gave you the picture on the screen. I hope you understand the sequence.
Was the look and say sequence, which was discovered by John Conway. Conway identified 92 audio-active elements, all composed of 1, 2 and 3. As well as 2 additional elements whose variation can end with any digit of 4 or greater. You might have seen me mention audio-active elements. For that we need to know about cosmological theorem. Conway's cosmological theorem asserts that every sequence eventually splits into a sequence of atomic elements, which are finite subsequences that never again interact with their neighbors. There are 92 elements containing the digits 1, 2, and 3 only, which John Conway named after the chemical elements up to uranium, calling the sequence audioactive. The look and say sequence was analyzed by John Conway. The sequence is also known as Morris number sequence or Conway's sequence. The Conway's constant. The terms eventually grow in length by about 30% for each number. In particular, if Ln denotes the number of digits in the row number n, then the ratio of L of n plus 1 to L of n is given by lambda, where lambda is 1.30577269034.
The look and say sequence has some interesting properties. For instance, starting with the number 22 yields an infinite loop of 2 2s. All the sequences grow indefinitely with a different seed number except for the degenerate sequence.
No digits other than 1, 2 and 3 appear in the sequence, unless the starting number contains such a digit, which is more than 3 of the same digits.
Sir Conway analyzed the sequence and found it as an equation with polynomial of degree 71, finding Conway's constant as its largest root.
Practical applications. Example: run length encoding. A data compression that was once used for TV signals and digital graphics is based on a similar concept. The amount of times a data value repeats within the code is recorded as a data value itself.
The look and say sequence was interestingly a sequence suggested to him by one of his students to him. After Conway completed his lecture, one of his students came up and asked him to guess the next number of this series, which he could not. And after the student explained him the answer, Conway got really fascinated about this series. And after he did his research, he published it in his paper, which he wrote in Undergraduate Magazine of Cambridge. He named his paper as The Weird and Wonderful Chemistry of Audioactive Decay.
Cases like these are good example of how numbers and other symbols convey meaning on multiple levels. Thank you guys for watching this video. Hope you liked it. If so, like, share and subscribe.